Alright, so we're gonna get started by taking out the steak out of the marinade that I had put it in for 2 days. I like to keep my steak in the marinade for at least 1 to 2 days. That way it just gets the most flavor when you take it out. Usually what I'll do is I'll put cooking wine and my two seasonings that I have right here, which I always use for all my steaks. It's just salt, pepper, garlic, and some steak blend that I use. I'm not sure what it is, but it's good. Now, to connect cooking this steak with all the activities that we have done in our classroom throughout the semester, I will start off with heat conduction, and this was a part of Act 1. Heat conduction is the transfer of thermal energy through direct contact, and it is vital when cooking. When we place the steak in the hot pan, it becomes part of this intricate reaction of heat transfer. The pan being in direct contact with the burner conducts heat efficiently, which ends up searing the steak and creating that very nice texture that you get on the steak. And it also causes the sizzle that you hear. For Act 2, the fire triangle activity and how it connects to cooking a steak, we'll be using this triangle picture. This triangle comprises 3 essential elements: fuel, oxygen, and heat. Let's focus on how these elements relate to combustion. Fuel, in the context of our kitchen, is the natural gas we use to ignite the burners. It's a hydrocarbon fuel rich in energy, and oxygen is drawn into the burner as we open the gas valve and supply it with air. Once ignited, the heat from the burner causes the fuel and oxygen to chemically react. This reaction is a fundamental process known as combustion. It's where the fuel and oxygen combine, releasing energy in the form of heat. In our kitchen, we control this reaction to provide the heat necessary for our cooking steak. We do this by being able to turn the knob left or right. The fire triangle illustrates that all 3 elements must be present in the right proportions for combustion to occur, just as in our stovetop. In Act 3, we delved into the world of cooking fuels. Our stovetop relies on natural gas as the primary source of heat. If you recall, we used a tiny container of fuel and burned it to see how many fuel would be left after lighting it on fire. Understanding that natural gas is a hydrocarbon fuel similar to those we used helps us appreciate the energy transfer involved in cooking. It's this chemical energy that powers the stovetop, making it possible for us to create the perfect sear on our steak. We are able to control the amount of flame that comes out of the stovetop burner using the knob so we can get the perfect. As we cook the steak, the heat initiates a process known as denaturation, which is a vital step in the cooking process. We've seen this process on an egg after being cooked and shown to us in class. Even in our kitchen while cooking the steak. Denaturation is where the proteins in our steak lose their natural structure and conformation due to the heat. But the magic doesn't stop there. The denatured proteins in our steak reform into new structures, coagulating to give our steak that perfect texture and flavor. While the steak undergoes this process, it goes through a lot of changes, like color and taste. As the steak cooks and cooks more, it gains an even richer flavor due to denaturation. One of our class's activities, which was activity 4, heating water to its boiling point, we heated water to its boiling point using a hot plate. This experiment focuses on a different concept but still illustrates the principles of heat conduction, much like how our stovetop burner, using gas and the fire triangle, fuel, oxygen, and a ignition or a spark, which would be the burner, starts a fire to then transfer heat onto the pan, which allows us to cook our steak. This experiment highlights the importance of understanding heat transfer in various different scientific applications, not just when cooking, but also when boiling water. Maybe you're making a coffee, so it can also be applied to different things. Lastly, I would like to go over some topics that I demonstrated in the video and also talked about. When we first put the steak down on the pan, you can see that the steak begins to cook on the outer layers and begins to get a nice sear. But throughout the video, you can see that later on, I begin to baste the steak with some butter. As the steak cooks, the hot butter in the pan plays a crucial role in the heat transfer because butter contains a lot of fats, and fats are excellent heat conductors. As you baste the steak super quickly, you're essentially transferring the heat energy stored in the butter onto the surface of the steak. This additional heat ensures that the outer layers can continue to cook while also penetrating deeper into the meat, but not getting right into the middle, so you can still have that medium rare steak. You can also temperature control with butter because you can control how much butter you're putting on top of the steak and how hot the butter is, depending how hot you want your pan to be, using the knobs turning it left or right on the stovetop. Basting allows for precise temperature control. You can use a thermometer to monitor the internal temperature of the steak. I chose to stick a thermometer in the steak after cooking it, but by frequently applying the hot butter, you can regulate the rate at which the steak cooks. As a result, the heat gently travels from the outer layers towards the center, ensuring that the steak doesn't overcook and remains medium rare. Lastly, as you can see, the steak here on the plate has a beautiful nice browning all over on the sides and on both bottom and top. This is because we gave it a good sear and basted it in butter, but it is also thanks to the Maillard reaction. The butter contains milks, solids, and sugars. When these compounds are heated, they undergo the Maillard reaction, a complex chemical process that results in browning. That's why the steak seems so brown and seared on the outside, and there's that crispiness to it. This reaction also causes the development of rich and savory flavors. Basting with butter enhances the Maillard reaction on the steak surface, giving it that desirable crust and deep flavor while still maintaining the medium rare and pink inside. Thank you for watching our chemistry cooking video about cooking a steak medium rare. And in the end, cooking a steak was a beautiful fusion of science and art. And by connecting these chemistry concepts to our culinary experience and understanding the benefits of research and relating our experiment, we not only get to satisfy our taste buds, but also get to satisfy our curiosity